All right, hi everybody. This is actually the lesson for today. All the other stuff we were doing was to get warmed up for this. Tangent lines, we have been doing this quite a bit, but here we go again. And in this particular way, we actually are just using the power rule, finding the slope and writing it in slope-intercept form. So if you remember, the derivative, let's just write this down. The derivative at an x value is the slope. And then you're just putting this into slope-intercept form. So we're going to go ahead and do this number one. And what we would have, again, is using the power rule. Multiply, subtract 1. That's a 1. Multiply, subtract 1. That's 0. So our derivative would be 2x, and that would end up being a 1, plus 6. And do you remember how that ends up being x0, which is basically 1. So let's just rewrite this. So we have 2x plus 6. And now we are doing finding the tangent line at -1, 4. So we are going to plug in the -1 to find out our slope, because it's the slope at that x value. So we would have 2, let's just write m, 2 -1 plus 6, which would equal 4. So now what we are doing is the slope-intercept and writing that equation of the tangent line. So we would have, remember we're going to have our slope-intercept form. And our m is the 4, and so is our output value, a 4 for the y. So we have the y value of 4. We have our slope of 4. We have our x value of -1. And then we just are figuring out what b is. So here we go. 4 equals -4 plus b. b is equal to 8. So what do we have? Our equation is y is equal, remember our slope was 4, our b is 8, and there you go. So again, that's finding the tangent line of this function at this point. And again, slope-intercept form. Okay, the next page is, alrighty, for number 7, we are doing something that we actually have not done before. And this is talking about finding the points where the tangent line of the function is horizontal. So if you remember, the slope of a horizontal line is 0. So what we need to do is we need to find the derivative and set that equal to 0. So if we have this, again, we are doing the power rule. So we have multiply, and that actually is a 1/2, you guys. Hold it, let me write this a little nicer. So we're multiplying here and subtracting 1. A 1 and a 1. Multiply, subtract 1. That constant is 0. So we would have 2 over 2 x to the 1. I'm just writing out all the stuff for this, you guys. 1 and x to the 0. So if you notice, that would go to 1. This goes to 1. We are left with x plus 1. Now, the question is, when is this slope 0? All we have to do is set that equal to 0. What is that x value? -1. So now it's actually asking us for that point on the function. So what we would need to do is to take this value and plug it into our original function, which we're going to erase a lot of this stuff from so that we can see what to do. So here you go. You're plugging in -1 here and here. So we have y is equal to -1 squared over 2 plus a -1 minus a 1/2. What does that give us? 1/2 minus 1 minus 1/2. So our y value is -1, which makes the coordinate point -1, -1. That's where the tangent line has a slope of 0. Okie dokie. That's for this one. You're to finish the rest of it. And that's today's lesson. Bye, you guys.